Hey there, awesome physics students. Let's talk about work, as in work and energy. Well, first of all, why do we care about work? It sounds a little bit hard and kind of boring. Well, the reason we care about work is that work changes kinetic energy. So that's why we care about work. Okay, so what is work? Well, the idea behind work is that we're going to multiply the parts of the force and the displacement that are parallel to each other. Force and displacement are both vectors. Interestingly, when you multiply the parts that are parallel to each other to get work, work is actually a scalar. So it's just a number, either positive, negative, or zero. Now, the units of work are determined by the units of force and displacement. Force has units of newtons, and displacement has units of meters. So the unit of work is going to be the Newton meter, which is a joule, the same as the units of energy. Interesting. Okay, so how do we take this idea, which seems a little vague, and make it mathematically precise? Well, let's imagine a scenario here where we have a box and we put a force on it, and we tie a rope to it and we pull on the rope in this direction. And by doing that, that drags it across, here's the floor, and it drags it across the floor, and the displacement vector points like that along the floor. And just keep in mind, this is not a free body diagram. I'm just drawing the force and the displacement together so we can see how this works. So here's let's say there's an angle theta between those two vectors. So how do I get the part of the force and the displacement that are parallel to each other? Well, let's just get the part of the force that's parallel to the displacement. To get that, we shine a flashlight down on perpendicular to the displacement, and that's going to cause the force to cast the shadow. That's going to be the parallel part, the part of the force that's parallel to the displacement. And so this will be the part of the force that's perpendicular to the displacement. We don't care about that. We only care about the part that's parallel to the displacement. Well, that part is adjacent to this angle, and so I'm going to take the hypotenuse here, which is the total magnitude of the force, times the cosine of the angle between that, because that side is adjacent to the angle. So that means that the work done here by this pulling force, by the rope, is going to be the part of the force that's parallel times the entire displacement, which is just going to be F cosine of theta, where theta is the angle between those two vectors, times the displacement. And these are all magnitudes here, so these are all positive. Okay, so what is this cosine of theta telling us? Well, if the two vectors are completely parallel to each other, so the force vector and the displacement vector point exactly in the same direction, then the angle between them is 0, and the cosine of 0 is 1. And that's telling us that these two vectors are 100% parallel to each other. If, on the other hand, the force vector is perpendicular to the displacement vector, that means that the angle between them is 90 degrees. Cosine of 90 degrees is 0. So these two vectors are 0% parallel to each other, and you're going to get 0 work if you try to compute this. The other scenario that you might see is if the force and the displacement are opposite of each other. So the angle in that case would be 180 degrees. And cosine of 180 degrees is -1. In this case, it's telling you that they point opposite of each other, and the work done is going to be a negative number. Okay, so let's think about how to use this just briefly in a very simple example. Imagine you have a ball that is only under the influence of gravity, so the only force on it is mg, and it falls and the displacement is a distance d down to the ground. How would I compute the work in this case? Well, the work done would just be the force, that's mg, times the displacement, that's d, times the cosine of the angle between them. But cosine, the angle between them is 0, so this is just going to be mgd. And these are completely parallel to each other, so the angle, the work done here is going to be positive. And the thing to notice here is what happens to the kinetic energy. The kinetic energy in this case increases. So the work done here is changing the kinetic energy. It's increasing the kinetic energy that positive work does.